We have been clicking icons on glass screens for almost 2 decades. But right now, the companies that build our operating systems are quietly tearing out the floorboards and rewriting the basic rules of what a computer actually does. Microsoft is minting standalone corporate identities, actual user profiles, not for human employees, but for AI agents. They are spinning up temporary cloud PCs just so these agents have a secure place to execute tasks before wiping the machine clean. Google is openly stating that Android is transitioning from a traditional operating system into a system-wide intelligence layer. And Apple is actively pushing developers to expose their app functionalities as app intents, breaking software down into invisible, structured actions so the system can operate the apps itself. No human clicking required. These are not random feature updates. Paired with a flood of recent computer science papers, they point to a coordinated, structural reinvention of how our machines are built, one designed entirely to manage autonomous AI. We are watching the birth of a second operating system, but it is not a replacement for Windows or macOS. This diagram shows the architecture of a traditional computing stack. A standard operating system does a very specific job. It manages physical resources, allocating CPU cycles, doling out RAM, and tracking network requests so your apps function. AI agents break this model. They require a system to manage semantic resources, tracking active context windows, managing compute budgets, persisting memories, and securely holding tools. This inserts a completely new layer between you and the machine. AI stops being an isolated application on your desktop and becomes the core mediator, translating what you want to do into the specific actions required to get it done. To understand how this second operating layer functions, we have to look at the invisible architecture running underneath these agents. In classical computing, the OS relies on a scheduler to slice up physical CPU time and distribute it evenly among running processes so your computer does not freeze. This new intelligence layer has a scheduler too, but it schedules cognition. It looks at a task and decides whether to route a simple request to a cheap local model on your laptop or send a complex reasoning problem to a massive, expensive cloud model. It also handles memory. When a normal computer runs out of physical RAM, it pages inactive data to the hard drive. The agent operating layer does the exact same thing for attention. When an agent's context window gets dangerously full, the system automatically compresses older information and pages those tokens into a vector database. It only pulls them back into the active reasoning window when the agent actually needs them to complete the current task. Running a persistent, autonomous agent is not just a matter of pinging an API. It requires deep, continuous resource orchestration to keep the model from stalling out or crashing the system entirely. But giving an AI the ability to think and act independently introduces a massive security flaw, known in systems engineering as the confused deputy problem. An agent scraping your inbox might read a malicious, hidden instruction tucked inside a spam email. Because the model processes raw data and system commands in the exact same context window, it can be tricked into using your personal credentials to silently forward sensitive files to an attacker. The only way to stop this is a dedicated control plane that enforces strict permission boundaries, separating the agent's reasoning core from the administrative tools it is trying to use. But the intense engineering required to build this security layer reveals a massive complication. This might not be a standalone operating system at all. Take Anthropic's Model Context Protocol, or MCP. It allows agents to securely access local files and databases. It functions exactly like a universal USB-C cable for AI tools, providing standard interoperability, but it does not have a kernel of its own. Are we actually going to buy and install a distinct second operating system, or is this intelligence layer just a collection of middleware protocols slowly being absorbed by the software we already own? That growing ambiguity has triggered an invisible, massive platform war over exactly who will control this new intelligence layer. In one future, hardware vendors like Apple, Google, and Microsoft win. They bake agent identities and local models directly into macOS and Windows, reducing third-party apps to raw capabilities that their native system intelligence controls. In a second future, cloud companies like OpenAI take control. The agent runtime lives entirely on their massive servers, turning your powerful laptop into a basic terminal that just streams a persistent, cloud-based intelligence environment. In a third, an open-source standard wins out. Neutral protocols allow the exact same persistent agent to float seamlessly across your Windows desktop, your Linux server, and your phone. The corporate battle over who owns this stack is still raging, but the architectural shift itself is locked in. The computers we use in the 2030s will not be defined by static applications or grids of icons on a screen. They will be defined by their always-running intelligent environments. We will probably never download a file explicitly labeled as a second operating system. Instead, the physical OS is officially stepping into the background, doing the quiet work of managing hardware so an entirely new layer can step forward to manage our goals.